I came across this tweet today that says, I've always felt sorry for the backend developers when they demo something that's really complex, but no one gets excited. Then the frontend team comes and demos a really simple UI and people go crazy. Well, frankly, I can feel this tweet with every bone in my body. Even as network engineers, we can fall victim of the same thing when we demonstrate something crazy complex networking technology, and we get gasps from the network architects, but our product management team, our products, and C-level board, they start checking their phones. Now, why is that? That is basically because it's not super fun and entertaining to see at the trace routes, pings, and terminal commands if you are not doing this day to day. So for the technical demo to be successful for both technical folks and some, C-level folks, you have to create this candy layer on top. And you can call it smoke and mirrors. I don't care, but it must be there if you want to, move your point across to different teams. So today we will look at the lab that our team in Portugal built. Basically, Tiago, Marlon, and Alexandre, they built a lab that's titled SR OS FP5 AnySec and MaxSec Demo. Even from the title, you can say that this is not a joke. This is something that's probably quite complex. Now, the way they built this demo is really exciting because they've built it in a way that got me excited. And I know that it probably will get you excited as well because they've built it in a very nice way with a very nice cherry on top. So before we start, let me give you a quick introduction what this AnySec thing is about, right? In the terms that the guys used in their README file, AnySec is a Nokia technology that provides low-level and line-rate native encryption for any transport, IP, MPLS, segment routing, Ethernet, VLAN, on any service at any time for any load conditions without impacting performance. Now, if I translate this marketing thing into something that I can understand is that AnySec is a line-rate encryption technology that promised to be quantum safe, so you wouldn't be able to crack the keys even when quantum computers are there. And it is supported on the head end and tail end tunneling endpoints, meaning that only P routers must support AnySec for it to work, but all the P routers may not. So you can only have these P routers enabling the AnySec capability without upgrading all the core, which is not the case for MaxSec, right? And at the same time, it is service enabled, meaning that you can enable it per service and not specifically per port, which is a nice purchasing thing for an operator to sell AnySec for a given service if it has been purchased. Okay, so I'm not an AnySec expert in any way, so you will probably talk to the team when you want to ask more technical things about the AnySec and how it works. What I will focus here is showing how they've built a lab and this automation panel that's into it. But before we start, here's the physical topology diagram of the lab. It has two P routers, P1, P2, two P routers, P3 and P4, two customer edge devices, CE5 and CE6, and two clients, Client 7 and Client 8. Now, in this topology, as I just said, only P1 and P2 enable the AnySec service. The rest is either MaxSec as the line between C5 and P1 and P2 and C6, or no AnySec or MaxSec encryption at all. But PEs will enable the AnySec end-to-end between the two routers. So we will see how it all works. On the logical level, we will have three services created between the provider edge routers. We will have the VLL, the virtual lease line, we will have the VPLS, and we will have the VPRN. Now, why we did create those three services? That is basically to show you that AnySec can be enabled on a per service basis and not on the port entirely. And that is, as I said, quite important for service providers. And then we will have three ports on clients. Port Ethernet 1 will use the VLL service, Ethernet 2 will use the VPLS, and Ethernet 3 will use the VPRN. So that's how the service decomposition is made. Now let's have a look how the lab presents itself when you deploy it. This is basically what you get. When the lab is deployed, you will have an IP address of the component in lab that presents you a web UI. And in this web UI, you see the usual flowchart plugin-based Grafana dashboard that shows you the topology, and we will talk about this more. But on the left-hand side here, we have a very nice automation panel. And this automation panel is what is really great, what is making this topology or making this lab exciting, both for technical folks and for managers. Now, you know that flowchart plugin exists for a couple of years. We've been doing demos with flowchart plugin Grafana dashboards for quite a while. I like it very much. Why it is important to use that? Because if you just show a diagram and it's drawn on the slide, it's not live. You cannot see the flows. You cannot see what happens to your topology. You do not see the encryption rates. You do not see anything, basically. It's just the static picture, a snapshot. What this plugin enables you to do is to bring your topology to life, right? You can now see that we have traffic coming from Ethernet 1 and Ethernet 3 interfaces with a certain bandwidth, and then it's all aggregated and spread it across the core. We see the encryption labels on the MACsec level and on the AnySec level for the selected service. And we can basically argue and explain how it all works. And it's like a magnet. People like to see that, and they would like to understand more how it works. It is way more cooler than just dull pings in a black terminal. Besides that, of course, you can have your regular panels, and this is all, of course, streaming telemetry based. So we use GNMIC, Grafana, Prometheus, the usual stack to get this data out. But then here you can say, yeah, we can look at the MACsec encryption statistics. We can have our tunnel labels and AnySec labels presented. So this is like a one-stop shop for your demo. You do not have to switch windows. You do not have to bring up CLI and mistype commands. It's all kind of pre-canned and makes the execution flow flawless. Now, what is happening with the automation panel here? The automation panel is basically your way to shortcut demo scenarios. Like right now here, we have started ICMP pings between the two clients with packet size 2K and the interval 0.1 second for VLL and VPRN services. Now, what happens if I click here and I disable the ping in the VPRN service? We will start seeing that once we disable the VPRN pings, you see that the rate here on the Ethernet 3 starts to decrease. And there is slow reactivity here because the rates are measured with the 30 seconds window. That is why it's gradually decreasing and not immediately like it really happens in the data path. But now you see that once I disabled pings on my VPRN, they disappeared from my Ethernet 3 interface. Now only VLL service is being pinged, or pings are happening in the VLL service. I can, of course, disable one of the ports, or basically what we say here, we disable the link. So we shut down ports on P1 and P3. So if we want to disable this link, we click on this button, and what we will see is that the admin statuses on the ports will start turning red, and the traffic flow that used to go through the upper edge of this rectangular core will start to divert to another leg, right? It will basically make you a live presentation or live demonstration how traffic reroutes without showing these nasty pings. I love pings, right? But the point being is that I can understand what pings shows, but a lot of your potential viewers will not. But everybody understands red, green, and lines taking shape and colored in a different way. So this is way more appealing, way more, gravitating to people's ability to distinguish things. So the automation panel gives you a nice, easy shortcuts to demonstrate your lab, how it works. At the same time, it reduces the chances of fat fingering the commands, and the execution flow becomes way more nice and easy. But then I wanted to show you how it is built. Now let me show you how the topology is built, the Containerlab topology. This lab is purely Containerlab based. There are no hardware routers. All the encryption stuff happens in the virtual data path that SRS executes. And this is exactly how the lab topology looks like. So we have our Nokia SRS kind, we have the Linux kind for the clients, and we have the nodes, right? We have P1, P2. We use different flavors of Ps and P routers. And then we have our CE devices and we have our clients. Now, what exactly enables this automation panel? We embedded the automation panel in the client 7 node. The client 7 node, as you can see, is a Linux container that uses the Alpine container base image. And then we created this setup client shell script. In this setup client shell script, we configure the IP addresses of the interfaces, but we also install the Flask server and we also install GNMIC client in it. Now, why do we do that? If you go back to our automation dashboard, you will see that this is actually not a Grafana UI. Well, this is a Grafana UI, but it's embedded into the web server. So the Flask that we install on client 7 runs a small static website with a backend. Yeah, it's not static. We run a small website with backend implemented by Flask, and this front UI is a little bootstrap website. We have just a few buttons and a few inputs. And when we click on stuff here, we call some JavaScript functions that are running in our browser, and they are calling the backend implemented by Flasks. So whenever we click on this button like VPRN here, what will actually happen is that the Flask will get triggered from the UI component, and the Flask will execute GNMIC command to enable pings, or it will connect to the clients to enable pings there with subshelling and connecting to the container and calling the ping command. But when we want to shut down the interfaces, we use GNMIC call to disable the interfaces there. It doesn't make sense to verbally explain how it works because, of course, we captured it all in the topology. It's all packaged in this Containerlab topology in this repository. So if you want to look at what's inside the shell script, how we install Flask, there's of course nothing crazy, just pip install Flask and you are done. But then in the web server directory that you will find under the config top directory, there is actually the app Python file that has the Flask code that reacts to the events from the JavaScript. And this is where the JavaScript code is. This is the script.js that captures the events from the buttons and whatnot. And there are a lot of hacks here, right? This is not the production grade web UI server, but it gets a point across. So it works. It's hacky, but it works. Now, the cool part is that you can deploy this lab if you have your SRS images on your Containerlab machine. So you can just type Containerlab deploy, point it to this repository, and you will see Containerlab checking and bringing it all to life. And then you will be able to reproduce the same steps and see how it all works. Now, I wanted to show you a little bit more about this automation panel and the way it works. As I showed you, you can disable the interfaces, you can start pings on different services, and of course you can change the rate of the pings and the size. So these inputs are not for nothing here. And once you change that, you can basically do like 20 bytes pings for every second, and there's like, you saw some slight validation happening in the front end side. So if we do this, and let's say I will disable the VLL, but I will enable the pings in VPRN, then we should be able to see that. And the interesting part about this automation panel is that it also very nicely integrates with our recent Wireshark enhancement in Containerlab. So if you will start using EdgeShark, and I have it in my tab here, you will be able to basically see the packets and see the effects of AnySec encryption by sniffing on one of the ports, either on the P or PE level, and see how it all works. So let's go back to our automation panel and look here. So now we have the AnySec running in VPRN, and the rate is small. It was only 20 bytes for each second, and that is why the rate is low here. But I should be able to start capturing packets on port number 2 of P4. Let's try that. So I'm looking for P4. Yeah, this is my P4 node, and I would like to capture from interface ETH2. So if all goes well, we should see the Wireshark interface in a couple of seconds. And then should see the packets that are coming, right? So we should see the encrypted packets, and that's exactly what we see here. So if I stop this, I should see the MPLS, because we are running SR OS in this demo. We see the packets. There is data, but it's garbage, right? I can't see the ICMP there. There is nothing that says there is an ICMP inside this packet. That's because we have AnySec enabled. But what will happen if I disable my AnySec encryption? So I will stop this capture right now, go back to my automation panel, and I will say that I will disable my AnySec for VPRN. So now again, I do not have to connect to my SRS node and reconfigure it on live. All I had to do is click a button. Now, if I go back and I start my capturing on port number 2 again, you see, I now immediately see the requests. So now the AnySec is not enforced anymore, and I can see the requests and replies. They are still packaged into the MPLS labels, but because it's not AnySec encrypted anymore, you can see the actual protocols. So I think the way to build labs with this automation panel and UI that explains the topology, explains the use case, is absolutely critical if you want your demo to be successful for various audiences. Not only technically experienced users, but also someone who thinks maybe from the business side or doesn't know the intricacies of a particular technology you're demonstrating, but is more interested in the overall solution and the benefits that it gets. For these different kind of categories of your viewers, having something like this is absolutely fantastic, because that would be an easy way to demonstrate the technology without pissing off one of those categories. And it's at the same time not so hard to build anything like that. As I just showed you, it's all based on open source projects. There is nothing proprietary. There is nothing you need to pay for. No paid products used. And at the same time, the value, the return, the ROI of that is enormous. I hope some of you will get inspired by what we've built with that, and of course, kudos to the team who did that, because that is something that we didn't have before. And now I think the next demos we will be building will definitely use something like this: the automation UI, the web UI for the topology, and some automation on the side to keep your demo inline, fluent, and looking amazing. So yeah, I hope you will check it out and let us know in the comments what you think about it. Till next time.